Hello, our names are Julian Kovos, Eric Alger, Neil Kathari, and Rachel Ryan, and we are here to present the analysis of the value-added and non-value-added work in the service process at a gourmet creamery. The family-owned ice cream parlor opened last year in downtown Ann Arbor. It has been especially busy during the past few summers, with lines running out the door. The manager is primarily concerned with the employees working under stress and the customer spending too much time in line. We have been asked to observe the steps in the serving process and provide recommendations to improve employee and customer experiences. The current layout consists of the serving workstation near the front entrance and a freezer with replacement ice cream tubs in the back. We ignored the dining area and kitchen. As you can see, each ice cream chest contains 2 rows of 4 ice cream tubs corresponding to a different flavor. In a typical order, a customer arrives and waits in line. When the line clears, after sampling a few flavors, the customer selects a cone or a cup, the number of scoops, and toppings. A server prepares the order and the customer proceeds to checking out. During peak hours, there are 3 employees, 2 that take and prepare orders, and 1 that makes waffle cones and processes payments. The main goals for this project were to increase the speed at which the ice cream gets served and to minimize fatigue and motion and transportation waste.
To evaluate the current process, we first interviewed the manager of the ice cream parlor and a server. During these interviews, we found that there were 3 primary issues in the serving process. First, since there is no restriction on the number of samples, customers can take advantage of this policy and try many flavors. Second, the customers often have questions about dietary restrictions for when they're ordering, which slows down the line. And third, there is a lack of space for the staff. As a result, many employees bump into each other. Next, the team conducted time studies for 2 tasks, taking and preparing customer orders and making a waffle cone. Using mode apps, we compared the difference in the normal time of each task to the average observed time for each task, based on 5 samples. The gaps between these 2 times were 12.9 and 4.4 seconds, respectively. These results indicate that there is a lot of non-value-added work when taking and preparing an order, such as fixing scooping errors and walking, but not when making a waffle cone.
Next, we used SketchUp to model the current and recommended work layouts. We superimposed 2 additional layers that represented a 5% female and 95% male. The overlap of all of the layers helped us determine the extent to which the servers reach to complete different tasks. As you can see from the parallel projection, which depicts a 95% male in the current work layout, there's a significant gap to reach the second row of ice cream tubs. Based on the other picture, servers must carry heavy loads from the freezer to ice cream chests. The shelves in the freezer also result in significant gaps.
Speaking of this freezer, we witnessed the top shelf posing a great threat to the 5% female. Therefore, we used 3D SSPP to quantify the strain of retrieving replacement tubs from that shelf on different body parts, estimating the load of a tub to be around 10 pounds. The results were staggering, as the shoulder itself exhausts in about 84 seconds when performing this action. When factoring in transport of the load back to the ice cream chest without carts, this becomes a dangerous scenario.
For the literature search, we found 2 papers using an extensive Google Scholar search. The first paper discusses advantages of a U-shaped work layout, including the ability for servers to oversee several workstations due to the reduction of walking in a more compact size, allowing for increased visibility, as servers are not blocked by each other or inventory. The second paper outlines techniques to reduce long-term wrist pain due to repeated scooping. First, you could reorganize the ice cream tubs by placing flavors that require more stress to scoop in the middle of the chest, where they melt faster. Second, since the paper found that ice cream becomes hard to scoop below -14°C, you could leave ice cream tubs out of the freezer for a designated amount of time before transporting them to the chests. Third, many new 8 scoopers now equipped with ejectors have been patented, and soaking them in antifreeze combines to make scooping much less straining.
Moving on to recommendations, we first suggest implementing a carousel system to replace the traditional ice cream tub layout. On the counter beside the ice cream chest, there would be a set of control buttons corresponding to each flavor. When pressed, the chest would automatically rotate such that the relevant flavor lies directly in front of the server. As illustrated in the SketchUp model and associated tables, this design would greatly reduce the reach requirements for a 95% male and result in a 30.2% increase in time efficiency. We also eliminated the freezer from the design, as replacement tubs would be stored in compartments beneath the chest to cut down on unnecessary transport of heavy loads, saving an estimated 45 seconds. As an alternative, the design depicted here is a more advanced U-shaped work layout. The current layout already employs a U-shape, but we feel that this is a little bit more effective. Instead of 2 rows of tubs, the extended U allows us to now have 1 row to decrease reach requirements. We've placed the extended U centrally to allow customers to circle around. Also, to address employee opinion, the server taking and preparing orders can now multitask without interfering with the server making waffle cones and processing payments, as the waffle maker and cash register are located next to each other. The next 2 recommendations are aimed at lowering customer waiting time. Flavor cards would contain extensive information about ingredients and provide icons for allergy warnings. If passed back and forth within the line, customers could plan what to order ahead of time. Meanwhile, while free samples would require another server, this strategy would allow the parlor to advertise and market new experimental flavors. We estimate the sampling period to decrease by 90 seconds per customer using both methods combined. Finally, we encourage the parlor to reorganize the tubs and install a waiting period during replacement to optimize melting, as described in the literature search. When analyzing worker movement using MODAPs, we also recognize that servers struggled using outdated scoopers. Therefore, we advise the parlor to invest in more advanced scoopers with an ejector and soak them in antifreeze. All 4 options will greatly ease wrist pain in the long term. That concludes the presentation. Thank you guys for listening. We are now open to questions.